We would like to invite you to start the lecture. Mr. Cyrus, you can go ahead so that we won't waste much of our time.
Thank you, sir. Can you hear me? Can you hear me well?
Yes, very well. I can hear you.
Excellent. So I will share my screen. Please let me know when you can see the presentation.
All right.
It says the host has disabled participant screen sharing.
Okay.
Okay, it says the host has disabled participant.
Yes, I think I've done that. Can share your screen now.
Okay. Can you see the presentation?
Yes.
Great. So thank you everyone for joining today. My name is Julian Cyrus. I am the Chief Operating Officer of Lunar Outpost. And I'm here to talk to you about air quality, a little bit about the background of air quality and the importance of it, as well as our Canary environmental monitor, which helps to monitor air quality and meteorological parameters. So a little bit about Lunar Outpost. Our company was founded in the US in 2017 and is located in Golden, Colorado. And we have multiple kinds of technologies that we develop. As you can tell by our name, we have a big focus in space and space technologies like our Lunar rover. But for today, we'll be talking about our IoT and air quality part of the company. So we also have offices in Luxembourg, and that's actually where I am at right now. And our offices in Australia are new as well. So as a company, we focus on three main departments, three main verticals. The first is robotics, like our lunar rovers. We actually have 2 rovers that are going to the moon this year, which is very exciting. And we work with NASA, we work with commercial space companies, and we work with the European Space Company or Space Agency as well. We have thermal control and energy storage technologies that we focus on here in Luxembourg. These technologies are for use in space as well as on Earth. And then we have instrumentation. And so in that instrumentation sector, we deployed the Canary. And so that has given us a good background in air quality and in the importance of it over the last couple of years. So air pollution. In general, air pollution is the presence of chemicals and particles in the air. These can have short-term and long-term impacts on people. These impacts not only are felt in the lungs and in the respiratory system, but it can have impacts on the brain, on heart health, on circulatory system. So it can basically affect, a large part of the anatomy and the physiology of a human being. Some of the key pollutants and key indicators that agencies like the Environmental Protection Agency in the US and Canada look at are sulfur oxides, nitrogen oxides, volatile organic compounds, or VOCs, carbon monoxide, ammonia, and fine particulate matter. So I'll go ahead and talk a little bit about some of the common ones here. With particulate matter, or PM as it's abbreviated, there are different sizes, and mainly we focus on the PM that's PM10 or PM2.5 in size. especially when you get to that PM 2.5 size of particles. When you breathe that in, it can actually permeate the membranes in the lungs and enter into the circulatory system. So it's very important to monitor these types of particles. They can come from sources that are natural, like dust storms or wildfires, for example, but they can also be caused by human sources. It's particulate matter is a very good indication of car exhaust. It's also present at construction sites, power plants, and those types of sources as well. And so, as I mentioned, it's one that we monitor very closely. And you can see in this next slide that these sources from the human side have these different elements involved. If you look back at the history of civilizations over the past century, the sources have changed. And so this is a constantly evolving topic. For example, even in areas with wood.
Excuse me, I think it's not properly shared. Share your slide very well. The slide is not properly shared.
Okay, so you're still seeing the
yes. What I'm saying is that share it very well. Put it on the on PowerPoint presentation.
Okay, I did enter presentation mode. Let me move this screen. Is this a different slide for you now?
Yes, okay, yeah.
Okay, I apologize for that. Yeah, we just went through a couple slides on, our company, and I'll just go back talking about the different outposts that we have, the different technologies, and this is the Canary, picture of the Canary. Next up is air pollution. Here you have listed the different types of pollutants that I listed verbally. And then talking about particulate matter and getting into the next slide, which is where I was at. And this is a source graph for different types of sources for human-made sources of particulate matter. And so next up, I'll talk to you about the total volatile organic compounds. These are from a large amount of sources. This is, most people actually are familiar with TVOCs, whether they recognize it or not. It's, when you smell paint, for example, or you smell gasoline or diesel, that is off-gassing of volatile organic compounds. And so these are, present in fuels, they're present in manufacturing processes, as well as other everyday household products like hairspray, air fresheners, and off-gassing. So the reason why we're concerned about these is that these can be considered carcinogens. There's a lot of different types of TVOCs, so some of these are more dangerous than others, but it's still important to recognize and monitor them, especially because they can have effects with other constituents or other types of pollutants in the air, and that can bring about other types of pollutants like ozone. So this is another graph showing sources over time with those. You see TVOC emission sources are very high in the transportation sector. That has decreased over time as, better fuels have been implemented. Also, if you're in an area with more electrified transportation, like electric buses or the monorails or electric cars, then you see a decrease in these as well. The oil and gas sector has a lot of VOCs and has a lot of methane emissions as well. As I'm sure you know, the oil and gas sector is actually the largest user of the Canary system that we have, monitoring for methane leaks and emissions, as well as inefficiencies in oil and gas systems. So overall, there are different types of pollutants. There's different types of sources. These come together and they add together for an air quality index. So this is an indicator of how healthy or how pure your air is. There are different ways of calculating this, and different agencies have different calculation methods, but this is one of them that is used by the U.S. Environmental Protection Agency that allows the public to better understand and have an easy way of understanding how good their air quality is. So that was a little bit of a primer on air quality itself. And so now I want to talk about actually then how to monitor that air and some good ways that we've seen in doing that as we've been in this industry over the past few years. So the system that we developed for it is called the Canary, and it is a real-time IoT environmental monitor. We saw that users in the air quality industry were using very expensive systems that had a high cost, to implement, like hundreds of thousands of dollars, and they had a large size. And because of this high cost and large size, it was not possible for cities, counties, states to have a full network of these stations. So we tried to create a small, compact, cost-effective device that is IoT, so it relays data immediately to an online dashboard. So we created the hardware itself, as well as the online portal, online platform that you can use to monitor and interact with your devices. So this is kind of how IoT systems typically work and how our system works. The Canary network or the hardware is out in the field, and you can see that displayed on a dashboard. All these different data points indicate a different Canary that is actually deployed in real life in Denver right now. So the city and county of Denver, when we first started working with them, had 3 monitoring stations in the entire county. And now, as you can see, they have dozens, which is very important because air quality as a measurement is very dependent on the location that you're at. You could be at one location near a highway, for example, and someone else a couple hundred meters away has a very different pollutant set and concentration at that location. So typically you have the hardware that's deployed in the field, and then you have the user that is looking at all this information. And depending on who that user is, sometimes it is an air quality officer for a city. Sometimes it's an environmental service company. Sometimes it's a community. So we try to make a system that is usable for all of those different users because there's a large range of expertise in the air quality field. Some of you, I'm sure, are experts in the field, and some of you may be kind of newer to the field. So that's important as you're creating a program to use a system that is proper for all those different types of people, and you can easily distribute the information as well to any stakeholders that you have. So the Canary database, this is important because this is, really what the user sees. This is the information that you gather is really the product that's being delivered. And with that, you want data that is actionable. So you don't want data just to, have numbers. You want data to be able to inform projects that you have and to be able to make decisions based off of that data. So, for example, when we worked with the city and county of Denver, one of the main projects they had was monitoring the quality of air at local elementary schools. So for young children, and they monitored specifically in areas where the schools were near areas of pollution, like highways, for example, and they wanted to distribute that information to the teachers and the students and the parents so that they could have information about when it was good for their children to go out and play. Also, when they were building a school, where to put the playground, for example, and to improve community awareness of air quality, which is especially important with at-risk populations, such as children with asthma, who can have a bad reaction to air quality that is poor in quality. This is just another example of the database and some graphing comparisons that you can have with it. So with systems that you're using, it's important to have the real-time data as well as data that is saved over time, so you can look back at historicals and do analysis on that. It's also important to have systems that provide you data regularly and are constantly monitoring, because the environment can change rapidly as well. So the Canary is actually constantly taking measurements, and then once a minute it sends a message to the cloud, and that is displayed on the database. So that's important because sometimes you have systems that only take a measurement, every hour or every, once a day. But that doesn't really give you all the cycles during the day, as well as if there's traffic patterns that you want to pick up on. You want to have more fine data that you're receiving. Okay, so ultimately what this is getting to, as I mentioned, we want to be able to provide customers with the ability to have scalable networks of cost-effective devices. And, we've had some customers in the past, like the City and County of Denver, the Environmental Protection Agency, the Department of Public Health and Environment in Colorado, that have used these devices. And here are, a couple of those projects. As I mentioned, we worked at the City and County of Denver on the Love My Air team. That's this team up here at a local school with the mayor of Denver. Another one was at the Matsky First Nation. So they are a Native American tribe in North America. We provided them with education on the system, similar to what we're doing here, and provided them with some devices where they're monitoring the railroad that goes through their property. Then the third is at oil and gas site. As I mentioned, this is actually the largest user in the U.S. And on this device, you can see that it's about the size of a shoebox. The Canary box is. It's solar powered, and on the top of the pole there, you see a device that is called an anemometer, or a wind sensor. So you can actually not only get the measurement of the pollutant, the concentration of the pollutant, but you can also get the measurement of the wind. So you can see where the pollution is coming from and you can attribute that to a source rather than just getting the magnitude of the pollution present, which is important, especially when you have, as you can see here, it's small in this picture, but you have an oil well on one side and you have houses or a community on the other. So, the community wants to know where these pollutions are coming from, and so does the company, the oil company. So next up is a little bit of information about different methods of monitoring. This is in particular looking at industrial settings, typically where you have alternative methods. For example, in oil and gas, sometimes you have service companies that are coming out and doing monitoring. Instead of having a device that is at the well, they have a technician come out once a month or once every couple months and take a handheld reading. And this is typical of a lot of environmental practices, but it doesn't really get you the data that you need because someone is only coming out once a month. So if something goes wrong, if there's a leak, then you don't learn about it for a long amount of time. Also, if there's a sporadic leak or problem, you might not even see it if you're coming out in such an infrequent manner. So that's another thing to consider in monitoring programs is the amount of time that is being reported or the amount of time that is being missed with your solutions. And then this is another kind of last slide about the different solutions that you can implement. You want ones that can have a lot of different pollutants. The Canary, for example, when we manufacture it, it's a modular device, so we can implement a VOC sensor or a particulate matter sensor or a CO2 sensor, just depending on the customer's needs. You want to have continuous monitoring, again, not one that is taking data once a day or once an hour, but truly every minute. It's got to be cost effective, obviously. Everyone has a budget, and you want to be able to have as many data points that fit within that budget as possible. Having one that is also reliable and resilient is important. You don't want a system that is made to be used just indoors, for example, and it breaks after being used for a month outside. You need a system that is durable, that can last through the year, wherever you happen to be. And the Canary product has been used in Arizona in the U.S., in Texas, where the temperatures are, over 40 degrees Celsius, over 100 degrees Fahrenheit, as well as in Colorado, in Canada, where you have temperatures that are, negative 20 degrees Celsius and negatives in Fahrenheit. You also want adaptable data integration. So the platform that I showed you is the web platform that I showed you for the data visualization is very useful for customers that don't already have a data platform. But if you are working for a company or you're working for an agency that already has a platform, then you want to leverage your existing capabilities. And so the Canary system can actually set up a webhook to route the data to a different database in case you already have that capability. And then the last use is the deployment. So, of course, you want to be able to deploy these in the environment that you're trying to monitor. You want to be able to deploy these maybe in a field that is not near a power source or not near Wi-Fi connectivity. Or maybe you want to deploy these downtown on a light pole to monitor the traffic patterns. So you need a source that will, or you need a solution that will meet the location and the deployment method that you are aiming for. So that is a couple more things to consider when trying to develop an air quality monitoring program, and pick a solution that will allow you to fulfill the purpose and the objectives of that program. So that was it for the presentation. I am available though for further questions, so I'll take down the presentation and I'm available for those questions as well as communications afterwards at this evening.
Yeah, thank you very much for your presentation. I think you can, okay, that is good. I think if we have questions, you can raise your hand up so that you'll be given a platform to ask your questions. And Mr. Sirius is ready to offer. Okay, we have Ife. Okay, you can go ahead, Ife.
Hello, good morning, everybody. Julian, thank you for your presentation. It's quite detailed. Just a few questions. Your device, has it been deployed in Nigeria before? That's my first question. The second question, I saw your structural architecture from the on-site where you have the device to the cloud, then onto the dashboard. Now, with your software, the question now is, with your software, can it be deployed to either a corporate organization without using your software?
Thank you for the questions.
Yeah. So let me stay on those two questions now, so I don't give you too many questions at the same time. Thank you.
Thank you, sir. To answer your first question, our device has not been deployed to Africa yet. We are currently deployed in North America, primarily in the US. We have, I think, about 3,000, 4,000 devices. We are also deployed in Europe. And the difference for a device that would be going to Nigeria is we just have to change the cellular communication module. But we do have that already tested. And so we just need to change that communication module so that it can work on a cellular network that is local. For your second question, with the software that we are using, the Canary can be used without the web platform. The device itself, it provides data in two ways. One is through the cellular network, so it sends the cellular network, the device, the information, and then from there it goes onto the cloud. And from the cloud, we can route the data to an endpoint. So that endpoint can be our online software platform, or it can be your online platform. The other way that it provides data is it saves it onto an SD card that is local on the device itself. So, for example, if you are in a location that has no cellular coverage, you can actually pull out that SD card and have all of the data on a spreadsheet that you can then. So the answer to your second question is yes, you can provide it without the web page software.
Right. Thank you. Any other questions?
Yeah, okay. And that takes me to my other questions.
All right.
You said the communication for Nigeria, you're working on that, and it's almost ready. Now you have either you're using a SIM card or you're using a Wi-Fi for your data transmission. Now, my third question now is, for the, I think someone's person is interrupting. Thank you. For the cloud, is it your own cloud if I'm taking your device? Am I using your cloud for data storage? That is the third question. And the fourth question, the device records and transmits data within a minute. You said it records the data in a second and transmits it in a minute. So it takes about 59 seconds time lag before transmission. Now, what happens to the data? Because it's going to be transmitting data of maybe 4, 5, 6 parameters. So you're going to be having those data per second being transmitted to my SD. Peradventure, I'm not using your software. So how do we correlate such a huge data coming into my SIM card or my storage on a daily basis for 30 days?
So for that, the first question that I think was about SIM card. With that, the device is. Right. I knew this factory when I was just a small kid. You, please.
My same age.
I know.
How do you know?
Please, we cannot hear you.
I was born in the street. Hello. Ejin, if you could please mute back on this. Thank you, sir. All right, so for the SIM card, the device does communicate over an electronic SIM card on the Canary, so it is not Wi-Fi. It will be over cellular. The way that we provide the data is we take the second readings and then average those 60 seconds into 1 minute. And then we send that 1 minute to the cloud. So that reduces the amount of data that is sent. Otherwise, it would be too expensive, you know, if you're sending every second worth of data. So we take those 60 seconds and then average it for the minute that is stored on the SD card on board, as well as that is provided in a JSON format for all of those parameters that you have. For the cloud storage, when the device sends information to the cloud, it's actually not stored at the cloud distribution point. It's stored at the database that you use. So if you use our online database, our website, then it is stored there. If you have your own, then the cloud sends it to yours, and that's where it is stored. So that's how the data transfer works. Yes, Epic.
Adu Alasan have a question. You can go ahead with your question.
Okay, good morning all. Thank you for the presentation, a wonderful one. My concern is on the VOC. My question is this. Is there anybody or, institution or regulatory body that's supposed to regulate the production of this VOC, volatile organic compound? And if there is, international body that is supposed to regulate this, the production of all this VOC. And if they have, why are they allowing a carcinogenous compound into this, allowing the manufacturers to use the carcinogenous compound in producing this product? Thank you very much.
Sure thing. Thank you for the question. There is not an international body that is regulating the production of TVOC products. Typically, it is regulated on a local level, and it will depend on the product itself, as well as the industry. So, for example, in the oil and gas industry in the US, it is done typically at the state level. So the state of Colorado has issued a regulation that says that the TVOC needs to be monitored for every new oil and gas well that they create. So it's typically done on the local level and dependent on the industry because, as I mentioned, the VOC is just a family of chemicals. There are a lot of different types that live within that family. And so also kind of for your second question, because there are a lot of different types, these different chemicals are potentially dangerous at different concentration levels. Benzene, for example, is considered a carcinogen at a level of, I think, a few parts per billion. So like, 6 to 10 parts per billion by the environmental protection agency. But acetone, for example, can be a lot more concentrated than that. So I think your first and second question actually complement each other because the regulation depends on the type of pollutant that you're looking at, as well as when you're considering how dangerous it is, it will depend on that pollutant as well. So I don't want you to think that everything is dangerous and everything's going to give cancer, but some do need to be closely monitored depending on the type and the concentration.
Yes. Thank you, Mr. Spiros, for coming. We really appreciate you. We appreciate your lecture. And I think your equipment is a very good one. And we hope that we continue to talk in the future and see how we can bring it down to Africa. I want to thank you for coming. We would like to thank all other participants who have really participated in this our Zoom meeting. And we will be bringing more of this type of a program through African Environmental Health Organization. We appreciate you all and we pray for you. God Almighty will bless all of you.